Alright, this video is for the class experimenting with probability and odds. And what we're doing in this worksheet is we're just doing some simple one event probabilities. So if you're taking this class, I want you to pause and grade yourself. If you're not taking this class but you would like to, go to the description. You can click on my profile and find all of my classes that I teach live on outschool.com. All right, so I'm going to assume that you have paused it. I didn't answer number 6 because we're going to discuss it because answers may vary. All right, so I'm going to zoom in and we're going to look at this. Okay, so first we got to remember what the formula for finding probability is, and it's basically events in favor over the total amount of outcomes. Now for the spinner, the total amount of outcomes are this spot, this spot, this spot, this spot, this spot, this spot. So there's 6 different total outcomes, and all the outcomes are represented by a color and a number. But there's only 6 places that spinner can land when I spin it. So the total outcomes is going to be 6 for all of these questions, okay? Now we got to look at the events in favor. So in the first one, what is the probability that a spinner will land on red? Well, there's only one spot that's red, okay? There's only one spot on the spinner that's red, so one event is in favor out of 6. And if you turn that into a percent, it's actually 0.16 into infinity, but round up to the hundredths place and you'll get 17%. What is the probability that the spinner will land on a 3? Well, there's only one event in favor. This one spot on the spinner, okay, is the only one that will give you that favorable event. So there's only one out of 6, okay? So I could write it as a fraction, I could write it as a percent. You could have written it as a decimal or 1 out of 6 as an actual phrase. These are all acceptable ways, but in this class we're going to kind of fine tune it because I can't be writing a million times when I do these worksheets. I'm going to write it as a fraction or as a percent. What is the probability of the spinner landing on an odd number? Well, there are more than one odd number in this particular spinner. This is an odd number, this is an odd number, this is an odd number. So in this one we have 3 events in favor of the probability and still only 6 total outcomes. So 1 out of 6, 1 over 6, or 17% is correct. Oh, sorry. I don't know why I said 1. It would be 3. There are 3 favorable events out of 6. So 3 out of 6, or you could reduce that to 1/2. I usually have a conversation about this either when before we do this worksheet or before we do odds. But in this class, no reducing. You can reduce if you like. You can give me the answer 3/6, or you can give me the answer 1/2. Whether or not we reduce a probability happens to deal with where we are in the data collection process. Because if I reduce it too early, then I can't go back and say, oh, there were 6 total outcomes. No, it looks like there were 2 total outcomes and only 1 favorable event. I want to keep my sample sizes consistent whenever I am doing this. So while you're still looking at data, while you're collecting it, every step before you submit your data for review, you want to keep it unreduced. Because of that, and because we're not actually submitting data to medical journals or business journals, I am going to leave that up to you. You can either reduce it or not reduce it, but I'm not going to be picky about that. So you could say 3/6 or 1/2 or 50% for answer number 3. Number 4, what is the probability of the spinner landing on an even number? Well, let's see how many even numbers we have on our spinner. 2, 4, 6. There are 3 favorable events out of a total of 6 outcomes. So it's going to be 3 over 6 or 1/2 3 out of 6 or 50%, some way you need to write that ratio. Because that's all probability is, it's just a fancy ratio. All right, so what's the probability that the spinner will land on peak? Unless you're colorblind, which is a very serious fact. And if you are, please contact me because I'll give you alternate sheets. We work with a lot of colors in this class. Don't just sit there silently because you're embarrassed. It's not a big deal. There is no pink on this spinner. And I gave you this on purpose because I want you to see that if there's none, then there's no favorable event. If the numerator of a fraction is 0, the answer is 0. So it's either 0 out of 6, 0 over 6, or 0%. Now, I'm going to ask you a question. Even though it's not on the worksheet, I want you to contemplate this because believe me, this is going to be a discussion question in the beginning of next class. So let's start working our minds towards it. And this discussion question is, okay, and it's probably in the classroom depending on the class. The discussion question is, should I have went back on number 5 and reworded the question? Was that an appropriate probability question? Or whenever we get a 0% or 100%, remember we talked about we need to go back and think about the question we asked. Think about the sample size we surveyed. Look and make sure there's nothing wrong because those are not common probabilities. So what should we have done differently with number 5? That is actually going to be our discussion question this week, so think about it. Now, I didn't give an answer for number 6 because answers will vary, so I'm just going to talk about some differences between empirical and theoretical probability. Make sure you have these in there, okay? In your something to this effect, okay? So empirical probability is when I do the experiment and I collect the data and I draw my conclusions about probability and odds, which is the next worksheet, from that experiment. Theoretical is where I do the math of what could happen, what is likely to happen, and I draw my probability results and my odds results off of the mathematical data that I generated. Okay, so one is actually playing the board game, one is just looking at the board game and trying to figure it out. Now, do these always meet eye to eye? No, there is more human error, there's more types of error depending on the situation. There can be all kinds of error, not just human error. Sometimes there can be mechanical error on empirical, whereas theoretical is more of it's a solid path of what it should be. So when we're trying to figure out the probabilities of something, especially in game board theory, we want to do both. We want to compare. We want to keep going back and changing things about our experience from our experiments, because statistics is kind of like a science math. We have to treat it like a math. We have to keep going back and looking at our question, looking at our sample size. What could we have changed to make this better, to improve our experiment and collecting data, just like you would do if you're doing a science experiment. You would go back, you would, collect your thoughts, conclusion, go back, change something in the experiment to see if you get different results. And that's what you have to do between empirical and theoretical probability in order to get them closer and closer together. We know we have some true probabilities when these two start to get close. They're never going to exactly be the same. And if they are, I would even say that there is some motive to go back and just check everything. But they're not always going to be exactly the same. Sometimes things are going to happen. And the point is to try to get them as close as possible. Okay? So those are the kind of things you want in there, but say it in your own words. I just want to know that you understand the difference between empirical and theoretical. All right, so keep doing this till you feel like you master it. Let me know if you need another worksheet. Play those board games, okay? I think for this worksheet, the corresponding board game was Chutes and Ladders, or Snakes and Ladders. We're doing the Snakes and Ladders version because it's free, downloadable online. So make sure you're playing that game and you're really seeing some real life application of these probabilities. I'll see you guys in class.